Welcome back to Cloud 42, I'm James. Today we're getting back to work on the Toolpost grinder. This is going to be part 9 and we're going to start work on the motor clamp. If you haven't seen the other parts of the series, there's a link to a playlist down in the description. Let's go over to the bench and take a look at the plans. This is the motor clamp. This is a slab of aluminum, 3/4 of an inch thick, and actually we're going to be running more like 725 or 700 thousandths. This is not the most up-to-date version of the plan, but the overall design is the same. So it's a piece of aluminum that has openings to clamp around the motor eccentric and around the spindle, and then the whole thing is slit through the middle, and then there's two quarter 28 clamping screws to pull it together. Now this would be a straightforward machining job, except that there are no parallel sides to hang on to machine this part. So the way we're going to do it is we're just going to take a block of aluminum, we're going to put it in some TalonGrip jaws, which we made in another video, and we're going to mill around this all the way down to a water line, so the part will be sitting, merging from a thin slab of aluminum that's left. Then we'll flip it over, hold it in soft jaws in the mill vise, deck off the remainder of the material, and chamfer the other side. So this is the piece of aluminum that we're going to use. Let's go over to the mill and get started. Okay, we've got our shop-made TalonGrip jaws here in the vise. And I've got the aluminum blank. I'm just going to put it in here and clamp down. Now we want to get enough of a bite that the jaws bite in and actually grip the material, but not so much that it warps the part and it starts bowing upward. When it's this thick, it's not going to be a problem, but as we mill material away, it's going to get thinner and thinner. So they say you should bite down hard enough to bite in 10 to 15 thousandths. I'm probably about 10 thousandths there, just judging from the gap that I can see. So that's the block. Got an edge finder in the mill. Now let's center up. The 0 point is on the top, right in the center. Okay, I'm going to 0 Y right there. Right there, I'm going to say Y divide by 2. And let's find the side in X here. And there's X 0. And there we'll do an X divide by 2. Now we're going to unlock the quill here and do a little bit of drilling, so there's no point in trying to set the Z height, because once we relock the quill we're going to have to adjust it again anyway. So the first operation, I'm going to get an 1.25" annular cutter, and we're just going to punch a couple of relief holes. The position isn't super critical, they're just relief holes for the other milling operations. And let's see, the first drilling operation is at G0, X minus 1.91865. You gotta love all the precision. Okay, this is the right location. Let's put a hole through it. I'm going to run this a little slower and see if I can keep it from chattering. There's a lot of cutter there. Now I'm just letting up by hand to try to break the chips. Get a little bit more coolant in there. Here we are, now we're through. Okay, let's move to the position for the other hole. And the other hole is G0 X 1.28765. This is just what the CAD program output. All those digits don't matter. Make sure that's in the right place. 1.287, 1.287. Okay, and let's drill one more. And there we go. That is through. Knock the little slug out. Can't get the chips off till I get the slug out. There it goes. And there are the slugs. 2 relief holes. Okay, we go back to the edge finder. Make sure we have tool 1 selected. And then we can set the Z height. And I'm just setting the Z height with a 10,000th shim. There we go, just clamped. So that will be a Z height of 10 thousandths. Okay, the first tool we're going to run as a CNC operation is going to be an engraving bit. Let me grab that. And this is just a single flute D-bit cutter engraving bit, and what we're going to do is we're going to engrave a horizontal line across here that we can use later to line it up when we put it vertically in the mill for other operations. Now we could normally, we'd wait and do this last, but since we have a facing operation and this raises a burr, we'll just go ahead and raise the burr and then come back with the face mill, and when we face it, it'll remove the burr. So we do these in a little bit different order than usual, and we avoid a deburring operation. Okay, there's the engraving operation done, and yes, it did leave a burr. Though the engraving itself is pretty clean. Okay, the next tool is the face mill. Torque that down. And let's deck it off. Okay. Nice. And the next thing we're going to do before we go any further is we're going to mill down to a minus 0.690. Now we already just faced it to minus 5 thousandths. So minus 690 in this case would be minus 685 from the top. So I'm just going to set a depth mic to that. There's 0, 690, 685 right there. And I just want to make sure that we are going to clear, should have 10 thousandths clearance over all these jaws, and it looks like we do. Good. I just want to make sure because we're going to cram a carbide end mill into the jaws if we don't. And yep, it took the edge off of that beautifully. The burr's gone. We just have a clean engraving left. Okay, this is the tool that will remove the majority of the material. It's a 3/8 inch aluminum specific end mill. This one's a YG1 high helix 3-flute polished. Solid carbide. Now these are the mills that end up with a lot of side load because you're taking heavy cuts, and they've got a high helix, and they're very, very smooth, so they tend to screw into the part. So I've got this one very tight in the collet, and it's very tight in the collet holder. So hopefully we won't have any problems, because if we pull out even 10 thou, we'll hit these hardened jaws and blow up the end mill, and that'll be fun. I'm just checking the setup sheet and make sure this really is the right tool. Tool 25, yep. Well, we've got a nice clean edges on the parts. The only thing I didn't like about that is that the entry and exit points as the mill came in and bit initially were just a little heavy. I'd probably take that in 2 passes of 10 thou each instead of 120 thou pass. But the finish on the outside is just fantastic, and we are about 10 thou above the TalonGrip jaws, which is exactly where we wanted to be. Let's see, next tool is an engraving tool, or a 45-degree chamfer mill, and put some chamfers on the top of this thing. And then we'll do some fit checking. Oh, that is beautiful. Boy, those TalonGrip jaws just worked a treat. I'm very, very pleased with that. Okay, I've been messing around with this a little bit off camera. After that last cut, the last contouring cut was 20 thou, and it left a pretty nice finish, but I went ahead and took a couple more spring passes because there's a lot of flex in this machine, and it was still taking off these very, very fine chips still. Now, after a couple of spring passes, the large bore has come more or less to size. This is the eccentric, and I can get it in, and so it fits. There's no perceptible movement at all. And so the large bore is done. That's going to fit the eccentric, and that's great. Now the other end measures out within about a half a thou of the diameter of the spindle. And so the spindle, you know, it looks like it should fit, but the spindle just will not quite go in. Small end is still just a little bit tight to fit the spindle. It feels like it wants to start, but it doesn't quite. Now if we look the diameter of the spindle down on this end is about a thou over 1.5 inches. And if we measure the bore, the bore says it's right about the same, just about a thou over. This is aluminum, and so the tool is probably indenting into it slightly. Plus there's probably some very small flat spots from the direction change. So I'm going to go ahead and take another spring pass, and if that doesn't fit, then I'll take another 1/2 thousandth off of it. Okay, this is just a spring pass on the small end only, inside contour. And that did take off some material, just the tiniest little whisper of a cut. Let's see if it fits now. Oh, it's very, very close. It wants to start, but it's not. Check the diameter again. Yeah, I'm getting still maybe a 1/2 thou shy. Okay, let me run this contour again. And I just told the cam to leave negative 1/2 thou on the wall. Okay, that again took a little whisper cut. And there it is, we're in. And that should clamp down just fine. Okay, parts fit. I'm going to call that good. Next step is to yank this out and put in the soft jaws.